Welcome to Dreamer in the Innovations projects. Today we are going to see about a very interesting project called Smart Agriculture by using Raspberry Pi board, Arduino and a wireless communication. So in this system we are going to monitor some parameters of agriculture land, such as whether the land caught with the fire and the temperature and the air temperature, air humidity for getting the environment data, and also we are going to monitor the soil moisture to check whether the land has the sufficient water. If it does not have the sufficient water, automatically the pump will be turned on to supply the water to the land via relay board. And also we have the wireless transceiver here. So this transceiver will send all this data to the distant server. So this is how the parameters are monitored in the land. So total system consists of Raspberry Pi board, camera, speaker, RF transceivers, Arduino, fire sensor, temperature humidity sensor, soil moisture sensor, relay, power for the pump and its power adapters. So this is the entire system. So this system consists of Arduino Uno. Arduino Uno will capture the data from the fire sensor, temperature humidity sensor, soil moisture sensor, and also control the pump automatically. And all this data will be collectively formed as a data packet and sent to the Raspberry Pi board via wireless transceiver. So this data will be received by another transceiver and given to the Raspberry Pi board. And Raspberry Pi board will also include one more parameter that to identify whether there are any animal is detected in the land, such as elephant, cow, and then other animals like other unknown persons. If any unknown persons comes, then also it will identify, and also identify the elephant and identify the cow and also identify the sheep. So we can identify whether sheep or cow is coming to the land and destroy the crops, and also to identify the elephant is coming or not. And after identifying the animal, it also do the process of preventing the animal from entering the land by using the speakers. So we need to place the speakers all around the land, and this speaker will produce a sound corresponding to the animal. For example, if the elephant is coming, it will produce a sound of honeybee, so that the elephant will fear of honeybee and it will go back, because elephant will always fear of honeybee. And similarly, when the cow comes, automatically it will identify the cow and it will generate the barking sound of the dog, so that hearing the sound of dog, the cow will go off. Similarly, when some birds, the group of birds comes to the land and destroy the crop, automatically the speaker will produce the shooting sound, and so that the birds will fly away. So this is how we can protect the land from the animals, and also we can get the data from the land and monitor it in the IoT. So all this data is sent to the IoT Blynk application. So all this data is sent to the IoT Blynk application. So by using that, we can monitor it from anywhere from the world. So this is how the entire system works. So now let us see the demo. Now let us test the project. So for testing the project, I have connected the Raspberry Pi board to the laptop using VNC Viewer. So Raspberry Pi board is connected to the laptop by using the VNC Viewer. So both the laptop and the Raspberry Pi is connected to the mobile hotspot. So and also you can see this is the Blynk application. So this is going to show the IoT data of the sensors. So here you can also see the Arduino is powered and all the sensors are activated. So the data that is received from the sensors will be transmitted using RF transceiver, and this data will be collected by the another transceiver and given to the Raspberry Pi. So along with the camera data, all the data will be updated to the server. So first of all, let me run the project. So this is the Python application. I am just going to run the project. So the project is being executed. So after executing the project, you can also see the Blynk server is being initiated, so that the IoT application will be connected. So here the data will be whatever. So this is the hello is the sound for the system initialization. So after that, we are getting the temperature data, all the data is here. So whatever the data we are getting from the Arduino board via wireless transceiver is shown here, and this data is also being updated to the Blynk server. You can see in the Blynk server the data is being updated. So the sensor data is updated to the Blynk server. And now what we are going to do, we are going to detect the animal and generate the sound that will irritate that animal, so that it will leave the land immediately. So for testing purpose, I am going to open the image of the cow. So the cow is being opened. So we have set the dog sound as irritating sound for the cow so that it will get off. So after opening the cow, you can see in the program the algorithm will detect the cow. So after detecting the cow, so we need to keep the image to the camera. Okay, so we need to keep the image that is visible to the camera. So after that, the algorithm will detect the cow. So now you can see the cow is being detected by the algorithm, and now what will happen? The dog sound will be generated that will irritate the cow to go off. So this data also being updated to the server. So after being updated to the server, you can see this cow data in the Blynk application also. So here you can see in the Blynk application also you can see the cow detected and the image of the cow being detected. And then I am going to change the animal now. So now next I am going to check with the elephant. So let me open the elephant image first. So this is the elephant image. So the elephant image is being opened, and you can see in the detection algorithm this data will be executed. So the system will, for the elephant, the honeybee sound will be generated and it will irritate the elephant. So the program is coming to the next loop, and you can see elephant is being detected. So after detecting the elephant, and that data will also be updated to the Blynk application. So you can see elephant updated to the Blynk application, and honeybee sound is generated. So let me open the birds. So if the birds come to our land, automatically the gun shoot sound will be generated so that the birds will afraid of gun and leave the place immediately. So now I have opened the images of the birds. So what will happen? In the next cycle, the bird will be detected. So in the next cycle, the bird will be detected. So after detecting the bird, automatically the gun shoot sound will be generated. So all the data will be updated to the server also, and also to the IoT. So there will be a certain delay. So now you can see the algorithm find the bird. So this is a bird, and now the gun shoot sound will be generated, and also this data will be updated to the IoT. So now you can see the bird detected, and also the image of the bird is being displayed, and this data is updated in the Blynk application also, and also the sound will be generated. So this is how the smart agriculture system by using image processing and the sensor network works. Thank you.